Hello everyone. I am Dr. V. Vaitheeshwaran, Associate Professor, Department of Computer Science and Engineering, Aditya University. Today I am going to deliver the topic on database management system, especially recoverability. What do you mean by recoverability? Before that, you should understand about the following topics are of the outcome of this particular lecture. Discussion about the recoverability, understanding about the locks and storage. These are the three topics student will be able to understand of this lecture. Recoverability. Recoverable schedule. A recoverable schedule is one where for each pair of transaction Ti and Tj such that Tj reads the data item previously written by Ti, the commit operation of Ti appears before the commit operation of Tj. In this diagram, T8 and T9 read of A, write of A, then T9 read of A, then T8 read of B, and this is called schedule 1. In T9 is a transaction that performs only one transaction, that is read of A. Suppose that the system allows T9 to commit immediately after executing the read of A instruction. Thus, T9 commits before T8. Suppose that T8 files before it commits. A written by T8, T9 has read the value of A. We must abort T9 to ensure the atomicity. T9 has already committed and cannot be aborted. It is impossible to recover correctly from the failure of T8. Schedule is non-recoverable schedule. Recoverability includes cascadeless schedule. In cascadeless schedule, we consider T1, T2, T3. In T1, read of A, read of B, write of A. In T2, read of A, write of A. In T3, read of A in schedule 2. Consider the schedule 2. Transaction 1 write the value of A, that is read by T2. Transaction T2 writes the value of A, that is read by T3. Suppose that T1 files, T1 must be rolled back. Since T2 is independent, T2 must be rolled back. T3 is independent on T2 and T3 must be rolled back. A single transaction failure leads to the series of transaction rollback is called cascading rollback. I repeat once again. A single transaction failure leads to series of transaction rollback is called cascading rollback. Schedules that do not contain cascading rollbacks are called cascadeless schedule. I repeat once again. Schedules that do not contain cascading rollbacks are called cascadeless schedule. A cascadeless schedule is one where for each pair of transaction Ti and Tj such that Tj reads the data item previously written by Ti, the commit operation of Ti appears before the read operation of Tj. Log based. Logs are very important. Logs are very essential for managing access to the data during the concurrent transactions. When one transaction is accessing or modifying the data item, a log ensures that other transactions cannot interfere with it, maintaining the data integrity and preventing conflicts. This process is called locking. Logs are very essential. It is, once again I am telling you, it is very essential to manage the data during the concurrent transactions. That means when one transaction is accessing or modifying the data item, a lock ensures that other transaction cannot interfere with it, maintaining the data integrity and preventing conflicts. This process is called locking. What are the types of lock? The first one is shared lock. Shared lock is also known as read-only lock. As the name suggests, it can be shared between transactions because while holding this lock, the transaction does not have the permission to update the data on the data item. S lock is requested using lock S transaction. Exclusive lock. Data item can be both read as well as written. This is exclusive and cannot be held simultaneously on the same data item. X lock is requested using lock X instruction. And then next we are talking about 2PL protocol. What is 2PL protocol? It is the two-phase locking protocol. It is a key technique used in database management system to manage how multiple transactions access and modify the data at the same time. There are two phases are here. Growing pace, shrinking pace. What is growing pace? In this particular step, the transaction gathers all the logs it needs to access required data. During the pace, it cannot be released any logs. Shrinking pace. Shrinking pace is nothing but once the transaction starts releasing the locks, it cannot occur any once. This ensures no other transaction interferes with ongoing process. Example of 2PL. So imagine a library system while multiple users can borrow or return the books. Each action like borrowing and returning is treated as a transaction. How the two-phase locking protocol works? The lock points are if the user wants to check the availability of X, borrow the book X if it is available, update the library record. So this is one example. Here, growing pace. User A locks the book X with his shared lock to check its availability. After confirming the book is available, user A upgrades the lock to an exclusive lock to borrow it. User A locks the library record to update the borrowing details. This is called growing pace. Locks are occurred. Second one is shrinking pace. Locks are released. User A updates the record and releases the lock on the library record. User A finishes the borrowing and releases the exclusive lock on book X. That's called shrinking pace. Locks are released. So now we are talking about timestamp ordering protocol. What is timestamp ordering protocol? It is a method used in the database system to order the transaction based on their timestamp. A timestamp is unique identifier assigned to each transaction, typically determined using the system log or logical counter. Transactions are executed in the ascending order of their timestamps, ensuring that older transactions get higher priority. For example, if the transaction 1 enters the system first, it gets timestamp TS of T1 equal to 007. Assume that value is 007. If transaction 2 enters after T1, it gets timestamp of T2 equal to 009. Assume that value is 009. This means T1 is older than T2 and T1 should execute before the T2 to maintain the consistency. Now we are going to talk about deadlock. What do you mean by deadlock? Deadlock is a condition in a multiple user database environment where transactions are unable to complete because they are each waiting for one resources held by other transactions. This results in a cycle of the dependencies where no transaction can proceed further. What are the characteristics of deadlock? The first one is mutual exclusion. Only one transaction can hold a particular resource at the time. Second, hold and wait. The transaction holding resources may request the additional resource held by the others. Third one is no preemption. The resources cannot be forcibly taken by from the transaction holding them. The fourth point, circular wait. A cycle of transaction exists where each transaction is waiting for the resource held by the next transaction in the cycle. These are the 4 different characteristics of deadlock. Once again I am telling you, first one is mutual exclusion, second one is cold and wait, third one is no preemption, fourth one is circular wait. These are all the various characteristics of deadlock. So deadlock characteristics are very important. To avoid the deadlock prevention, we are going to use the various types of facilities available in database management system. Now we are going to talk about storage. There are storage, we are having different types of storage: volatile storage, non-volatile storage. Volatile storage means it does not survive system crashes. Example, main memory, cache memory. Access to volatile storage is very fast. It is possible to access any data item in the volatile storage directly. Non-volatile storage, such survives even the system crashes. Disk, magnetic tape. Disks are used for online storage. Tabs are used for archival storage. Both subject to the file year may result in loss of information. Non-volatile is slower than volatile storage. Disk and tape devices are electromechanical rather than based on the chips as it is volatile storage. Stable storage, the information residing in the stable storage is never lost. See, after this, recovery and atomicity play a very important role in the database management system. Transaction Ti that transfer 50 from account A to B, initial value of A and B is 1000, 2000. System crash has occurred during the execution of T1. There are 2 recovery procedure: re-execute Ti, that means A becoming 900 rather than 950, and system enters into inconsistent. Don't re-execute TI. Current values of 950 and 2000 for A and B. System enters the inconsistent. When a DBMS recovers from the crash, it should maintain the following. It should check the states of all the transactions which are being executed. A transaction may be in the middle of some operation. The DBMS must ensure the atomicity of the transaction in this case. It should check whether the transaction can be completed now or it needs to be rolled back. No transaction would be allowed to leave the DBMS in an inconsistent state. So we are having one recovery algorithm to discuss about this. The recovery manager of the database management system is responsible for ensuring atomicity and durability. Atomicity, undoing the actions of the transaction that do not commit durability, such that all the actions of the committed transactions survive the system crashes and media failure. There is algorithm that is called arrays. Algorithm for recovery, isolation, exploiting semantics. What is arrays? ARIES. Algorithm for recovery and isolation, exploiting semantics. After a crash, the recovery manager is involved to proceed in three phases: analysis, redo, and do. Analysis: identify dirty pages in buffer pool, changes not yet returned to the disk, and identify active transactions at the time of the crash. Redo: repeats all the actions starting from proper point in the log, thus restoring the database state to what it was at the time of the crash. Undo: undo all the actions that did not commit to database, reflects only the committed transactions. In this recovery algorithm, in the log records, there are having 6 steps. Update T1 writes T2, update T2 writes D3, then T2 commit and T2 end, then update T3 writes D1, update T3 writes D3, then crash happens, then we are going to analysis T1 and 3V and then undo the current transactions, and T2 committed and write the dirty page, write and dirty pages D1, D2, D3, redo it once again, do the updation of 1256, undo 156. Summary: these are the learning following topics we have discussed so far: recoverability of database management system, logs and storage. Thank you very much.